When you were a child, you might have wondered if the universe has an end. If it does, what do you think it would look like? A. The edge of the universe is nothing, but it keeps expanding as the universe grows. B. The edge of the universe is a boundary with higher dimensional space, causing incomprehensible changes to anything crossing it. C. The edge of the universe is an infinite stone wall, trapping humanity inside. Or D. The universe has no end, and no matter how far you travel in any direction, you'll always see various celestial bodies. Which one do you hope for? If the universe has an end, and you shoot a laser from Earth into space, assuming the laser doesn't spread or weaken, could it avoid all celestial bodies and reach the edge of the universe? What I mean is, there are far more celestial bodies in the universe than you can see. Even in seemingly dark areas, there are many stars just too far away for their light to be visible to the naked eye. For example, the Andromeda Galaxy has a diameter of 220,000 light-years, but its light takes 2.5 million years to reach Earth. After traveling such a long distance, the light appears faint in the night sky. But if its light didn't weaken, wouldn't the sight of the night sky be breathtaking? So, the night sky is dark not because it's empty. Does this mean that any laser you shoot from Earth would inevitably be blocked by a star? If we assume the universe has no end, then in an infinite universe filled with countless celestial bodies, any laser would eventually be blocked. But this leads to a problem. Although distant stars appear dim, their number is infinite. According to the inverse square law of brightness, no matter where you look in the night sky, you wouldn't see darkness. Even cosmic dust would be heated and glow. So, the night sky should be as bright as the surface of a star. But the current universe doesn't look bright. So does this mean the universe is finite? Not necessarily. Even if the universe has no boundary in size, it wouldn't be bright because the universe is only 13.7 billion years old. The light from stars 13.7 billion light-years away hasn't reached Earth yet. But the main reason is that the universe is expanding, causing all galaxies to move away from us at a certain speed, known as the recession velocity. The farther a celestial body is, the faster its recession velocity. According to Hubble's law, celestial bodies 13.3 billion light-years away from Earth have a recession velocity exceeding the speed of light. While a celestial body emits light towards Earth at the speed of light, it also accelerates away due to the universe's expansion, eventually moving faster than light. By the time its light reaches Earth, the celestial body could be much farther away, which is why the universe is 13.7 billion years old, but the observable universe is 45 billion light-years across. This doesn't mean we can see objects 45 billion light-years away, but that the objects we see now are currently 45 billion light-years away from us. We don't know if the universe has an end. Since light can't keep up with the universe's expansion, just like a beam from Earth can't catch up with receding galaxies, it won't reach the universe's edge. Stars are drifting away, so we'll see fewer of them over time. Even at light speed, you'll never catch them. They still exist, but you'll never see them again. Remember to say, if I never see you again, I wish you well at all times of the day. Cherish what's in front of you to avoid regrets. Before this video ends, don't forget to like, comment, and subscribe.